Hello everyone, I'm Andrew Culham with Shibogama Technical Services in Sioux Lookout, Ontario. You may recognize me from the First Nation Housing Community booth and also helping Jan Eeks at the First Nation Housing Conference. Today we're going to be talking about cellulose insulation. So a lot of people wonder what cellulose is, and well, it's basically recycled newspaper and paper products. And here I've got an example right here of what it is. Sometimes if you look closely, you can pick out what year the newspaper was printed on. So what I like about cellulose is its ability to slow down the transfer of air through a wall cavity, and the fact that it's used from recycled materials, and it's got a low embodied energy from not taking a resource and turning it into something different. You're actually using something that's a byproduct of something else. So you're able to recycle and reuse something that would naturally be either thrown in the landfill or repurposed. So the other thing that's nice about it as well is it's fire retardant. It's treated with a natural chemical. It's called borax, which gives it it stops rodents from getting into the insulation, which is key for stopping the air transmission through the wall cavity. And then also it's fire retardant as well. So if you get another 25 minutes out of a burn if you happen to have an unfortunate fire in your house. Chris, I don't know. I've got a video here that I did of burn of the cellulose at my house there, just outside my garage. If we could play that. So here I put a washer on top, and what that does is it gives it extra heat to show the burn. You can see it's not really burning, it's more charring the surface and then it's smoldering itself out, and that's the fire retardant that is the borax. It's a natural additive. And some people, when I talk about cellulose and how that it's recycled paper, they kind of question, why are we putting recycled paper? Paper is extremely flammable. Why would we want to put this in our house? But as you can see, it's not actually igniting. It's just smoldering itself, and that's because of the borax. It stops the oxygen from burning. Plus the insulation itself stops air from moving through it. And the carbon footprint, it's 80% less than used in like insulation, like fiberglass or rock wool, because of the fact that it is using a recycled product. You don't need a lot of heat to make it, like where rock wool you would need extreme amounts of heat to actually produce rock wool. Same with fiberglass. You're crushing and you're using a lot of electricity and energy, and your carbon footprint is reduced by not using something that's a new material. The other nice thing about cellulose that the R value doesn't change with the temperature, because with fiberglass, if it's not 100% airtight, you can lose a lot of your R value by the air moving and creating a convective flow within your wall cavity. Where with cellulose, it stops that air from flowing, especially if you're in a wall where you dense packed it. It doesn't allow air to travel through the wall space. And it works the same way in the summer as well. So if you're air conditioning a building, it does the exact same thing. It doesn't allow that convective flow to begin. Just waiting here for the next PowerPoint. So for installation, equipment. There is a couple things that you need. You need an insulating blowing machine. This is my blowing machine here. It's an AccuOne 9500. I bought it for a couple of reasons, and I know Jan and I talked last week on the webinar about why you purchase certain types of materials. You do your own research, and you find what works best for you from where you're located. If you're in a northern remote community, you might find that a different machine works for you based on parts availability and customer support too, because I know in our communities up in Northern Ontario, this brand doesn't necessarily work all that well because you're waiting for a long time for the parts to repair. Where for me, I can get the parts readily available, and it works pretty good. But essentially what you have is you have a large hopper on the top. You can see in this picture, you can see those blades, they chop up the bales that you buy. In the background beside my machine there, you can see the bales. They're about a 25-pound bag, so they're not too heavy. I've had a couple of mishaps before where I've dropped a knife inside and it's jammed up the machine, but those are little things you learn along the way when you start using an insulating machine like this. You figure out the things that you need to do and what you need to do to prevent any issues from happening. But it's a fairly simple machine to use. This machine here is another machine that's available. This is the one that I would suggest for the northern communities that I go to, based on the fact that you can get all the parts in Winnipeg. If you are looking at a machine and you want to be able to do more than one purpose, and you don't want to just blow in attics, you want to be able to blow in wall cavities, you need to really look at the machine and make sure you get a machine that works for doing both. So this one has the ability to do your attic insulation plus your wall insulation, your dense packing. And it's just a different setup with the machine. It's got different, it's got blowers, so it'll actually inject the material instead of just pushing it. And the other thing with dense packing is you need to be certified. I actually got certified as an instructor and an insulator. So, which is beneficial because I can train in our communities and get people within our tribal council certified so they can purchase and install in the walls and attics and understand the machines better, and understand the best practices for insulating. I mean, it's like any other insulation. If you're going to use spray foam, you need to be certified to do that. It's just sometimes hard in remote areas to have someone willing to go and do the training that is required to install properly. There are some safety equipment that you're going to need, the proper PPE. I choose to wear a respirator, which is just my choice. I mean, you can wear an N95 mask. There aren't anything. Anytime you break down a material, there's going to be dust. You'll see in a video in a bit here that it can be a little dusty, but the nice thing is it's not itchy, so you don't have to worry about having a cold shower every night after insulating. Sometimes you wear goggles as much as you can, or safety glasses, just to prevent it from getting in your eyes because of the dust. To me, it doesn't hurt, but I have also read the MSDS sheet, so I understand what's in the material and I know how it can affect you, and there's also the long-term effects too. So that's why I always suggest that whenever you're not familiar with a material, you should be asking for the MSDS sheet so you can read up on your own and you can be 100% familiar with the material that you're working with, so that you know that there aren't any long-term effects that, if you're not protecting yourself properly, that could happen later on in life. So talking about the proper application of where you should and where you shouldn't use cellulose. And I feel the same way with any type of insulation. Every type of insulation that's available on the market today, there's a good place and there's a proper application, and then there's an application that just doesn't make sense. Or maybe there's a better material that does a better job at insulating. So For me, I really like using the cellulose in the attics. It fills in all those nooks and crannies and around wires that you otherwise would have to cut bats of insulation and fit, and it's just time consuming. You don't get a nice tight fit around electrical boxes. A lot of times I see where someone's just jammed it into a space, and what happens there is you allow an airspace, and then any heat that's going to escape is going to create condensation in that spot because the insulation is crushed and it's not doing its job, and you're reducing that R value in that space. So the other area I like to do it as well is in the walls. I personally have had to do some work in my own house, and I've been replacing the fiberglass bats with cellulose, and it's amazing to see how many areas where mice have got in and tunneled through it. And when you have a tunnel through your insulation, that's just basically a highway for air to travel through, and you can see where the cavity is turned black from the air moving from the bottom of the wall to the top of the wall. Where if you have dense pack in there, it provides you with a high level of sound deadening because it's a denser material, and also doesn't allow the air to travel, and the mice and rodents and insects will not burrow through it like they would fiberglass. You'd think they would because of its paper. You'd think they would love that stuff, but with the borax, which is what they add into it as a fire retardant and rodent and insect repellent, they don't travel through. They won't touch the stuff. I mean, they use borax on anthills and things like that to deter them and get them to go away from your house if you have an ant infestation. So it just makes sense that it's put into the paper. The sound deadening, you can put it between floors, which is really beneficial. Plus, also, it can aid in fire retarding for party walls, and even if you have an apartment above your house or between apartment floors, it can be used that way too as sound deadening material. It can be used below grade on a case-by-case basis. I don't necessarily recommend it because if you do have any water issues, the one issue with it is just like fiberglass. Once it gets wet, it takes a really long time for it to dry. And that's why, I would suggest using like a rock wool or a styrofoam or something different. Just based on that, that's why I said a case-by-case basis. You're going to kind of see what makes sense. I was in Alberta for a while doing construction, and there was the housing boom where they were insulating houses before finishing houses before the siding was put on. And one issue that they ran into was when the rain hit the side of the house, rain would run down the sheeting and then get into the wall cavity and create problems with either fiberglass or cellulose or even rock wool too. So what they had to do is they had to put a little Tyvek paper strip between the two layers of plywood to shed the water away. It was just interesting to see how the building code in Alberta had changed based on something that you would think would just be done like siding. You'd think the siding would be done before you'd have drywall or having people move into houses, but things happen and you got to come up with other solutions. So all right, so now we're going to talk about the attic and wall installation of cellulose. So with your blower, when you're doing an attic insulation, you're not necessarily trying to pack the material into an area. You're loosely filling it around all the trusses and your electrical outlets. And the one thing that I always like to make sure is when you go up into an attic, you make sure it's air sealed. And some people wonder what air sealing means. And it means that anywhere you have a penetration through your vapor barrier, you want to make sure that it's 100% airtight, that you don't have any holes that can allow air to transfer through. And even though cellulose does a really good job of stopping the air from transferring through the insulation, if you have a little hole, you're going to actually create vapor now. And that's another issue that you can have. And it doesn't matter what type of insulation you have. When you have water or vapor building up in one area that's concentrated, you're going to have a big issue with a cold spot, and you're going to have with cellulose, it's got a mold inhibitor in it, so it's not going to allow mold to grow. But that area that's wet could potentially freeze, and then now you could have a larger area that is leaking, and then you can get condensation built up in your attic and cause a lot of other issues. So air sealing is very important. Whenever you're installing, and I'll show a chart here too, because the R value is higher per inch than your typical insulation, it's R value is 3.7 per inch, opposed to most insulations other than styrofoam that is usually, like your rock wool and your fiberglass, are around R3 per inch. So you can get away with having less insulation blown in with the cellulose than you would typically if you were to blow in even fiberglass insulation. So when they give you the chart, they tell you how thick you have to be with it loose filled, and then over time it does settle down to a certain thickness. So that's already been taken into consideration with the calculation that they give. So here I've given an example of, for our 50, you go 15 inches thick, and then when it settles out, and it might take a year to settle, it's 13.4 inches settled, and that gives you the R value of R50. Here's another chart here, so you can pick your R value and set your thickness to that. And the other thing that you need to do when you're putting it in is your attic stops. If you're going to live in an area that's colder, you ask for a larger attic stop, and you do the same thing with fiberglass too, because you need that airflow to stop the ice damming and things like that on the edge of your roof, where you usually have a little less insulation. So here's an example. I have an Attic-Cat measuring tape, and I was installing cellulose. It kind of looks funny, but it gives you, I staple those throughout the whole attic, and then that gives me an idea of where I'm at for thickness. And in the background there, you can kind of see the insulation stops. They're just cardboard. They're like a wax-coated cardboard. So if you're putting them in during installation, or while you're framing the roof, they don't deteriorate with rain and stuff like that. There's another picture there looking back towards the attic access. The other thing I'd like to point out too is an issue that you can have with cellulose is wind washing the attic or the insulation, where if you have a ridge vent, it works very well because the air just flows straight out through the roof. But if you have too much ventilation in your attic that allows too much air to cross flow through your attic, it can actually push the insulation from one side to the other. And you can have the same thing happen with fiberglass, but it ends up being dirt that gets packed down on top. And I'll have some pictures later on to show what that looks like. But you want to make sure that you have your housing inspector or your housing technician look over the plans and tell you what you need for proper attic ventilation, so that you're not over ventilating your attic and causing extra airflow through there that could cause issues with it. There's another picture. You can see the tape there, and a better idea of the hose. The cord that I've got running through there is actually the remote control that I have for controlling how much insulation is being put in. So the person installing the insulation has total control of the machine. You can leave it where you just blow air through it if you have to push or you want to clear the line out, or you can have it where you're actually pushing material through the hose as well. And there's a picture after it's installed. This is actually my house. I pulled out all the fiberglass and replaced it with cellulose because of the issues that I had with mice throughout the house. There's a picture there too. It looks like I've just got foam, but I do have foam baffles, but I do have cardboard baffles there too. So with wall insulation, there's a few steps that need to be taken to do a successful job. One, you need to be certified. So as an installer, which means you're allowed to purchase the material, because they don't, it's like styrofoam or spray foam. They don't want to have just anybody installing it and then having issues and then everybody blaming the product and then the product gets a bad name. If you are certified to do it, you've done the course, you understand the material, you've worked with the equipment, so you're familiar with how the machine works. And it's like anything else. Once you get used to using the machine or the machine that you're using, you're going to understand how it reacts to different situations. Like I can listen to my machine and I can hear when I'm at the proper pressure in the wall, because I always pack to a density of 3.5 pounds per square inch, which can be measured too. I know if you wanted to inspect, you'd actually take a 1 foot cubic square out and then you'd measure that area and you'd know if you've got it packed properly. But there's other ways of doing it as you're installing, and that would go, you would learn that in an installation course for cellulose. And here's the netting. Here's one way of doing it is netting the wall. You need a lot of staples. You need to make sure the staples are along the edge. You can see in the picture that the staples are right on the edge and they're running vertically instead of horizontally. The reason I do that is with one staple, you get twice the amount of holding power. There's a lot of other reasons why I staple like that too, not just on netting, but just personal preference. But for right here, you definitely need to do that, because the worst thing you can have happen is if you don't put enough staples in there, you'll have a blowout, or you'll have cellulose get in behind the netting and the stud, and then now you're going to have an issue when you go to drywall, because even 1/8 of an inch of material is going to create issues when you try to drive a screw in there. You could break right through, or later on have nail pops. So it's really important to have enough staples there to hold it all together. So there's the wall after it's netted. All your electrical boxes can be just pulled through. And what I do over the area where you've got an electrical poly hat is I just put a piece of foam over it, and that stops any blowout around that area or dust or insulation from popping out around there. It makes it fairly easy. Another picture of more staples. And there's some insulation baffles. So this job is a fairly tricky one, because it's not just installing cellulose on your walls, it's also areas, because this has got an apartment above, there's areas where there's attic space. So this area right here where you see the pink attic stops, I'm actually filling in that area with loose fill. So I've left it open so that I can blow it in, and then when I get to the end, I can blow it in to the right thickness, right at the very last bit. So I'm not trying to crawl around in there. I'll just put the netting in, and we'll strap the ceiling and then fill it in as we go. Another area there too with the attic, and you kind of see the wires and everything. So if you were to put fiberglass in there, you'd have to cut around all those wires and try to insulate that and make sure you've got a tight fit and a full coverage over top of your exterior wall plate too. So it could be challenging and it time consuming. And I know the netting seems like it could be a difficult thing, but once you do it a few times, you're very familiar. You can become very familiar with it, and it becomes easy and kind of a second nature thing, just like putting up paper barrier. Another picture there with more netting. And then this is where I was talking about the attic space. So it's a vaulted ceiling, and rather than putting baffles through the whole truss, we ended up using styrofoam. So like I said before, we've combined different types of insulation to get the highest R value in this application. That end wall, that dormer end, actually goes straight down through to the garage, above the garage door. And we did actually put some stops in there, because you need to have some sort of a stop for support too, for the insulation, because you can only go about 10 feet before you need to put vertical block or horizontal blocking in. And then on the peak, that's all going to be loose filled above there. That's not going to be dense packed, because we don't need to dense pack the ceiling. We really have to go with our 15 inches of insulation to give us our proper R value. You do have to do a little bit of extra planning to make something like this work, because you have to vapor barrier after. And there are other options too. There's smart vapor barriers, which I'll show here, that allow you to put on your netting plus your vapor barrier all in one, which it's expensive, but it can save a lot of time. I'm going to show you a video here of me actually insulating a wall cavity. So I've got my piece of foam there to stop any blowout from there, and you can actually see the insulation climbing up the wall cavity in the video here, and it's filling in around all the wires. It's actually plugging the holes that have been drilled through the studs to allow wires to go through. I do a couple different systems for when I'm installing. Like I'll blow in from the bottom to ensure that I've got proper density at the bottom of the wall. I'll also do a hole in the middle to make sure, same thing. I'm not trying to push all that insulation straight up. I'll get the bottom filled, I'll get the middle filled, and then I'll do the top of the wall. And there's different processes. Everybody's, as long as you can get the proper density, everybody's gonna have their own tricks. What I like to do is I'll do a whole wall section at one level across the bottom, then I'll go back across the middle, and then I'll go across with a scaffold or a ladder to do the top. And in my hand there, you can see the cord. That's actually my remote for the machine, so I can turn it on and off. And what I'm doing there is just changing the direction to kind of blow some insulation up. And there you go. You can see the insulation being pushed up into the cavity. The other thing you have to do as well is I always roll the wall after. I take a 2x6 and I will put it up against the insulation without pushing on it. And if you have a little bit of a space between your stud and your insulation, not too much, but a little bit of a space, then you know that when you roll it, you're going to have enough density in that wall, and then you're going to push it all back into place. It's going to kind of compact it into the wall cavity. You make sure it's rolled, and the drywaller's not going to hate you for leaving it all pushed out. You can kind of see the ripples right above where I just touched there. Those are there because I haven't blown it in from the top down. Yeah, I explained also, like with the rolling, you roll it to flatten it out, and it pushes it. It increases your density when you roll it. It's basically like a fancy paint roller. And here is the smart vapor barrier that I was talking about, which also works really well in a retrofit. If you're doing a renovation to a house that you're having to take drywall off, you can use this and actually build a service cavity wall in front, which works really well for reducing any kind of dew point issues that you might have with mold and things like that you notice in corners of buildings. With doing the option on the right of your screen, you can run all your wires and have less penetrations through your vapor barrier. And you're also strapping it too, so that you don't have to worry about any blowouts. You don't have to put as many staples into place for the netting and the vapor barrier. But like I said, this is it's a more expensive vapor barrier, but to me, it's worth it. You get kind of do two steps in one. So for renovations, you can do attic insulation repairs. Like I said, with my house, I had mice burrowing through. They actually destroyed the vapor barrier. So I've been questioned why I would pull out all the existing fiberglass insulation and not just blow more on top. And what that's called capping. And when you cap the roof, you're not actually repairing any of the damaged vapor barrier or insulation. You're allowing that air to flow straight through that damaged insulation, create the condensation above your vapor barrier that's damaged, or any penetrations that are going through your attic. And you're not going to stop condensation issues that you may have in your attic because you're still allowing the air to flow straight through. And I know cellulose will slow that down, but over time it's going to build up moisture in the insulation, and then it's going to create other issues later on down the road. So for me, I would rather just pull out all the old fiberglass or whatever type of insulation you have, repair the vapor barrier, air seal it. I personally like to use spray foam over the top of the wall plate. It just ensures that your vapor barrier is sealed to your top plate properly. And I'll actually spray foam from the top plate to the attic stop, and it stops the attic stop from blowing out if you happen to have a blowout, because it kind of bonds the two surfaces together. And then once you do that, you know that you're actually really improving your insulation, because I mean you lose 50% of your heat through your attic, so why not take the extra care and do it properly, and then you can walk away from the job and feel comfortable that you've actually made a big improvement, and there aren't going to be any issues later on down the road. Here's some pictures of just the fitment of fiberglass. I've always found it very awkward, even when you do take your time. Can be difficult. Sometimes people are in a rush when they're doing it, or it's just awkward to use in the middle of summertime when you're trying to be covered up, because it's very itchy to use fiberglass, especially if you're either over your head or you're in a hot attic. It can be not a very pleasant place to be. So oftentimes you see spaces and gaps and areas where it hasn't been put in properly. You can kind of see this is supposed to be a white insulation, and you can see what happens when you've got too much airflow in your attic. You can actually get a fine layer of dust, which over time will press down on the insulation and cause it to lose its R value that way as well. Another picture here. This is where I think someone might have walked up across the top of the insulation to do some maybe repair or add some circuits into an attic. So where if you were to walk into a cellulose attic, you could bring a broom with you and kind of fluff it up again after you're done. There's a really, really damaged insulation. I think that's probably from someone either storing something up in the attic or walking around doing some repairs. And once it's like this, it's pretty much useless anyways. Like, you can't do much with the insulation because it's been destroyed. And actually, if we go back one there, you can see how there's an insulation stop on your right-hand side, and then right straight ahead, there isn't one. So that's where you can get ice damming issues, when you have your insulation touching the sheeting, because you don't have that airflow across between the insulation and the sheeting. So like I said before, for renovations, you can add to your wall insulation, or if you have to do repairs. I did some repairs in my house where I had rodent issues. There was a bit of water issues in one corner of the house. There are a few different ways you can do it. I did mine from the inside, where I pulled the bottom 4 feet off the insulation. I was able to reach in, pull down all the insulation out of the wall, and I just kind of draped the vapor barrier up over top of the drywall that I left on. You can, if you don't have insulation in the building and you're wanting to re-insulate or insulate from fresh, you can drill 2.5-inch holes, and then you run your hose up into the hole and then fill the cavity. Where if you have like a vinyl siding or something that you can remove fairly easily, you can also cut a horizontal strip around the building and then pull the insulation and do it from the outside and then patch it without even going inside the building. So here's my house where I had pulled off the bottom 4 feet of insulation, and I actually dense packed it. And what I suggest for anybody interested in doing this is getting a thermal camera, because then you can make sure that each one of your stud cavities is filled properly, because it's harder when you can't see what you're doing. And over time, like I said, you get better at understanding and hearing the sounds that your machine makes while it's being blown in. But I used a thermal gun, and I was actually able to see where the insulation was in the wall cavity, which helped out a lot. And then I actually re-vapor buried the bottom section, because that's where I had all my plugs and everything else. So I just wanted to ensure that I had a nice tight fit around that area. Here's the type of hole I was talking about. There's a 2.5-inch hole that you can allow to you can reduce that 3-inch line that you use for blowing in the attic, and you can push it up into the attic space, and you push it up into the wall cavity. I mark mine by foot. So if I'm in the middle of the wall, I'll mark it every foot, and then I know that I'm all the way down to the bottom of the wall when I hit that 4-foot mark, or whatever height your wall is, you can just mark it off. And then basically what you want to do is you can fill it with the plug that you cut out, and then you want to repair your air barrier on the outside before you put the siding back on. So we have some multiple choice polls that we've put together, and we're just wondering if you could put your input on. We've asked what type of insulation you're most familiar with, and your input is great, just to see what people around different communities are using in their walls or the attics, or even the crawl space or basement, what you're typically used to using. We've got a few people with fiberglass and rock wool. I've done quite a bit of fiberglass insulation, and I know they say rock wool's not itchy, but it's the dust that gets to me. But I like it, and I use it in a lot of different places too. It works. It does work really good for repelling water as well, and the styrofoam I have here is the expanded polystyrene, which is the beads, or you have your pink or blue XPS, which you typically put on the outside of the building as well as to prevent thermal bridging through your studs. So looks we got 60% of people use fiberglass. That's typically what you see. You see a lot of fiberglass. Being out west, like I lived out in Edmonton for about 15 years, and there was probably more fiberglass than dense pack, but it was definitely changing with different environmental things, programs that were coming out. I know Ontario had an EcoFit program, and they were changing over to just different options, things that work better. Like I know cellulose worked better in an attic than fiberglass did, because it's easier to install and have a nice tight fit. So, and it isn't that hard to install. It's fairly easy once you get the machine set up and you're ready to go. And it can be done fairly quickly. Like a 900 square foot house, I can have insulated. You need a helper, someone to load the machine, but a couple hours and you're done. Are there may be some questions here too that we could go through? Does anybody have any questions regarding insulation or
Good morning, Andrew. We do have some questions that have come in via email, and I'll just read a couple of those too. Just wanted to let everybody know that we've opened up the chat box at the bottom of your interface. If you'd like to type in a question, Andrew can see your chat there, and he can make an answer for you. Also, that if you would like to speak to us directly, you could just raise your hand, and we'll activate your camera and microphone, and we'll get you going live here. While we're letting our guests get themselves organized there, Andrew, I have our first question came in from Mr. Harry Miller from the Dakota Ojibwe Tribal Council. And Harry wants to know, is it possible to make cellulose insulation either on the job or as an economic development initiative for the tribal council or the First Nation?
I think anything's possible. It can cost quite a bit of money to get a startup if you're talking about actually making the insulation yourself. I think maybe the best thing to do would be to talk to some of the manufacturers that are out there right now and see if they can set up maybe a manufacturing plant up in a community or close to a community that you could benefit from. Because it's not something that easily that you could, it takes quite a bit of organizing. Like there's a couple different parties involved. There's usually a large city that provides the paper, and you need someone who's going to provide you with clean paper. You don't want to have a lot of garbage in it and things like that that could create issues manufacturing it. I think like what I'm doing right now is working on training people in the community to install, which I think is really beneficial to the community, especially if you're doing eco retrofits or anything like that, or new construction. With an attic, it is less expensive to install than your typical rock wool or fiberglass insulation. It's the time and it's the material itself that is less money. It is something that's made in Canada. And it's I think like I said, I think anything's possible. I think you could definitely talk to some different manufacturers and see what the availability is to do like even a joint venture or something like that. But yeah, and then I think we've got another question here. So after cellulose is installed in an attic, how hard is it to do electrical rework if required? So the nice thing about cellulose is whenever I would do a rework job, I'd take a dustpan up with me and I would just figure out where you've got to do the work and then push it off to the sides, kind of like you're digging a hole, and then leave it on the sides. You do your work and then you just push it back into the place and make sure it's the right thickness. I mean, you just have to kind of even it out. And then as you leave, you do the same thing. You even it out and make sure that anywhere you stepped, you've kind of fluffed it up again. So it's fairly easy.
Hi, Andrew. We've had a couple more questions come in, and I'll read you two of them at the same time. The first question is, are there any harmful chemicals used in making cellulose? And part two of that question is what do you do to dispose of unneeded or leftover cellulose?
Okay, that's a good question. So with cellulose, because it's a paper product, they have added a fire retardant to borax, and some manufacturers add a couple different things. So I'm not going to say it's 100% safe. You always have to follow the manufacturer's instructions. And like I said before, an MSDS sheet to make sure that there aren't any other harmful chemicals in there. But from the product that I use, there aren't anything. There's nothing toxic in it. So I still protect myself with an N95 respirator, and I wear coveralls. I just wear coveralls. I don't like having that kind of stuff on my skin. I like to go home without being covered in insulation, get in my vehicle and stuff like that. So I just find it better to be protected. As far as disposing of it, it's safe to go if you have to get rid of it. Like let's say you're doing renovation and you find that there's cellulose in there. There's it can go into, if it's damaged or whatever, it can go into the landfill. It's not going to cause any issues there. It's just actually going to break down. They use a lot of this same type of cellulose as a hydroseeding material, so that rather than putting borax in it, they put in fertilizer and they put grass seed in, and they can actually make grass grow with it because it bonds to the surface. It's got starch in it, and then it stays after it gets wet. The other nice thing too is when you're actually insulating and you have any insulation like come out of the machine or go onto the ground, if you have a magnet, you can just make sure you're not picking up any nails or screws or anything metal or large debris that might have been left on the floor, and you can put it back in the machine and reuse it. It's not garbage. Like I know typically when you're doing rock wool or any kind of insulation that you have to cut, whatever offcuts you have, you try to use them up, but at the end of the job, you're always left with extra pieces and they end up going to the landfill. And, you know, it takes a long time for that man-made products to be broken down, where this can be just reused. You have any more questions there, Chris?
Hi, Andrew. Yeah, for sure. Another one just came in, and hoping I'm transposing it correctly here. They want to know what issues do you have when you try to dense pack a wall?
So some of the issues you can run into, I think I explained that before, is blowouts, where you don't put enough staples in to your netting. And I mentioned before as well, any type of insulation is the same thing. If you get water in the insulation, it becomes saturated. It's almost useless, and it can become very hard for that wall cavity to dry out properly. You know, with rock wool or fiberglass, more so with fiberglass or even dense pack, if it gets heavy enough, it can actually start to settle to the bottom. So it's really important to make sure that you have your air barrier at least on the outside of the building before you insulate, and making sure you're putting in the right space. You could do it in a crawl space wall or a basement wall, but then you run the risk of like having, let's say you had condensation build up on the backside of a concrete wall, or you had your waterproof membrane on the outside of your PWF foundation get compromised, and then you had a water leak. Well, it's going to create issues. So I'd rather not install it in a crawl space because of that. So those are some of the issues that you can have is water and just installation issues. But once you get familiar with it, you'll find a system that works, and it doesn't take that long to make a couple mistakes to correct them. Are there any other questions, Chris?
Any questions we received via email. If anyone have any last minute questions, please feel free to raise your hand or type them in the chat box. Otherwise, we'll let Andrew wrap it up.
Yeah, it's been really really great to be able to be part of these webinars. Over the last, I know this is my second one. First one was with the Onyx, and we discussed screw guns and everything. So it's been a lot of work, but it's been worth it, I think. I'll let you have a look at this material one more time before I close things up, just so you can kind of get an idea of what it looks like. So this is the wall bar stuff and it kind of breaks apart, but if I take it and I squish it into a ball, it'll stay together. Where if I did that with the stuff meant for your attic, there's your wall bar, which is meant for your walls, and then the other stuff that your loose fill, which is meant for your attic, and it doesn't have the same kind of binding materials, larger particles of recycled cardboard and paper and things like that. So I think what I'm going to do is close things out. I'd like to invite anybody who has any new topics that they'd like to see covered in upcoming webinars. Please share those ideas. They mean a lot to us. We want to make sure we're giving you the content that you want to see. We want to see your stories from your communities, your success stories, the mistakes, projects that you've done. You can visit us at our Facebook page at the First Nation Housing Community. There's also a survey at the end of the webinar. It'd be really helpful if you could fill that out. And like I said, it's the feedback that really makes these webinars successful. Next week, we're going to have Jonathan Gregg talking about the housing inspector on October 21st. And then the week after is Section 95 and the dynamic return, or Section 95 and the new application process for doing that. And that's on October 28th. And if you could please register for the webinars online at thefirstnationhousingcommunity.com and subscribe online for news and updates. Get the latest updates directly to your inbox, which is an easy way to see what's going on around the First Nation housing community and what kind of events and webinars that are upcoming. I'd like to thank everybody for participating. It was great to be here, and we'll see you again next time. Thanks.